Today, we're talking to Paul Jeffries, South Central Reforestation Advisor for ArborGen and a lifelong forestry expert. His job? Helping landowners grow stronger, more valuable forests, whether for timber investment, wildlife habitat, or keeping land in the family for generations.
Each individual landowner has his or her own management objectives.
And if you think America's forests are disappearing, Paul sets the record straight.
We have more trees in the United States than we had when Christopher Columbus discovered them.
Thanks to advancements in genetics and technology, today's trees grow straighter, stronger, and with less waste than ever before. And if you think trees are just standing there quietly, think again.
Is it true that trees can talk to each other?
Yes.
This episode is packed with insights on reforestation, forestry's future, and why the trees we plant today matter more than ever. Let's get into it.
Welcome back to the Wood World podcast. On this episode, we're going to have an incredible conversation with a friend of mine. His name is Paul. We'll ask Paul to introduce himself in a second. Man, I've been looking forward to having this conversation on our episode because you'll hear from the man, the myth, the legend himself. This guy is impressive. The first conversations we had and to set the stage, we've met at a conference, and I felt like, Paul, I knew you for a long time. Listen, can you give us a little blurb? What's your name? Where do you work? And give us a little taste of the knowledge base that you've got.
So I'm Paul Jeffries. I am Reforestation Advisor for ArborGen. I cover Alabama and Mississippi and part of Tennessee. I live in my hometown where one of my family properties is in Detroit, Alabama. And I went to school at Mississippi State University where I majored in forestry. Um, got my bachelor's degree in forestry, a master's of science degree in forest genetics, and then got my PhD degree working in bottomland hardwood, working in sweet gum, cherry bark natural stands in the southeast, looking at growth and yield. So I have a varied background. As I was growing up, I just had such a love and passion for the outdoors that when it came to going to school, there was no question of what I wanted to major in. But once I got into the field of forestry, it was very difficult for me to narrow it down to specific disciplines because I wanted to do it all. I was just passionate about the environment. I was passionate about wildlife. I was passionate about forest, timber, trees. I was just I guess my favorite thing in the world outside of my family, my faith, is the outdoors and trees and the natural environment.
Paul, my goodness, man. It's going to be exciting. So, the first question I love asking when a guest joins is where in the wood world do you fit? Because as we define the wood world, man, there's a lot that goes on. We're talking about, all the wood world, how we define it is, starts all these value streams that you got with wood and wood products. And that all starts way up in forestry with the seedlings and all of what we're about to talk
Right.
about, sneak preview. But then there's so much value streams. You've got the forests that get harvested and then sawmills make lumber, and you've got all the lumber products value streams, and you've got, all these other types of hardwoods that get used for other types of purposes. And so, man, there's a lot to unpack. Where in the wood world, Paul, do you fit?
So I guess you could say in the wood world, where I am right now, would be in the beginning.
Mm-hmm.
Kind of like in Genesis chapter 1, in the beginning. So I work with ArborGen and we produce seedlings for reforestation.
Mm-hmm.
So one reason why I love my job and passionate about what I do is because I help landowners pick the seedling the genetic, and we'll get into that a little bit later, but as to what that is, but I help landowners basically paint their painting, their tapestry of what they want their private property to be like. What do they want to leave to their children and their grandchildren? What do they want it to be? Do they want it to be a productive pine forest? I work with landowners to get them the right product to meet that objective and to make them successful.
So ArborGen, that's your current employer. And what's a day look like in Paul's life? You mentioned it a little bit. You're meeting with private landowners, you said, or maybe public land. Or like, who are you meeting with? Who do you actually work with? What's a day look like in Paul's life?
Well, I don't know if I can describe a day, what a day looks like in the life in my life, the life of Paul Jeffries. I would say, depending on the time of the year,
Mm,
the my day is spent working with, meeting with private landowners,
mhm.
meeting with forestry consultants, meeting with foresters, meeting with tree planters and service providers. So it's very rare that I have 2 days back to back that I'm doing the same thing,
Mhm.
because I am meeting with groups, I'm meeting with individuals, I'm speaking with, like I said, service providers. So an average day in my life is having a lot of discussions about seedlings and genetics and the benefits of replanting and the success you can have when you have a proper management plan and it's implemented.
So, Paul, is it safe to assume that on a daily basis you're working with folks who are familiar with all these topics that are hot topics in the modern day, or are you having to educate people? Like, what's that process look like when you meet somebody? Are they already educated? Are they well aware of their options, how today's decisions impact long term, or are you having to educate them, Paul?
Well, and that's a very good question. Actually, I have a lot of both.
Okay.
So before I came and accepted the job with ArborGen, I was a instructor at Mississippi State, and I taught classes and taught students. And I took that experience into my career with ArborGen, and now I spend a lot of time with landowners who don't know exactly what's available to them in the way of seedlings, and I help educate them on the new technology that has come out, and it is technology.
Mm.
Genetics is the same is technology, just like the latest cell phone. And seedlings is technology, just like the latest computer that has come out. So it's just like that technology. It's ever evolving. So I work with landowners, educating them, and then I'm also helping educate foresters who may not be working with this all the time and may not have all the information about what they can make available to their clients, and then working with service providers, they may not be aware of this new product or this new family that has come out. So I'm educating a lot of people,
Paul, I
helping
mean,
educate.
that's incredible. And that's definitely what I saw in our first conversations together, and why I was really excited to invite you to the podcast, Paul. Is I'll just list here when I asked Paul, hey, what kind of topics can we dive into? I loved your answer. Well, I can talk about everything forestry. We can talk about, you mentioned to me, I'll read a list: private landowners, renewable resources, woods to goods, sustainability, markets, genetics, silviculture, reforestation, afforestation, wildlife, and the list goes on. And I was like, all right, this might be a multi-series podcast episode, but listen, I guess when you go to meet with people, what are the common things that you're hearing, and that maybe you could start weaving those? Give us a taste. Paint with a a wide paintbrush right now. Just give us a taste of those topics that maybe I listed or others that come up as you're doing your work. What are these common topics you're having to speak about?
Well, and that's one reason why I like forestry so much is there's so many topics and there's so many rabbit holes you can go down and everything. But you know, every landowner has their different objectives. And this landowner, for instance, may only be focused in timber management and timber product production. But typically, your private landowner, they're interested in um, timber production, but they also have an equal interest in wildlife habitat improvement. And while I'm not a wildlife biologist by education, I can help through, education in helping them merge those two objectives to reach an overall objective of what I call just ecosystem management.
Mm,
And all of those topics that you just listed is
mm,
something that goes into and should go into every management decision that's made. Am I going to reforest? Well, first of all, when am I going to do the harvest? When am I going to perform the harvest on my stand that is existing now? How am I going to re-prepare the site for the next stand that's going to be planted? Am I going to do natural regeneration? Am I going to do uh, uh, artificial regeneration, replanting? Am I going to machine plant, hand plant? Am I going what and within each one of those major topics are sub tiers. So going
mm,
back to site prep, am I only going to chemical site prep? Do I have enough fuel on the ground to do a site prep prescribed fire to get the site ready? Do I need to machine plant or hand plant after that? So all of those topics, the field of forestry is very dynamic and it's a large ball, I guess you could say, of disciplines. And so as a forester and with the people that I'm meeting with, I have to have knowledge in every one of those facets. So, it's very diverse and very um, um, convoluted, but it all works together for a common goal, and that is ecosystem management, the environment, and making sure that the wood products that are needed in today's economy are being produced to the best that they can be produced. And it is all very um, 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 there's little waste. It's all very very all everything is used.
Paul, here at a high level, where the audience of our podcast are two groups of people. The one group is the ones that go to association meetings, are more aware of the benefits of wood and wood products. They are convinced that it's good to use and to participate in the forest management, all these things. The other group of people that are listening here, don't know all the details of the things that you just listed. And I think that you know kind of a broad statement here, but when, let's say, one of these folks who are just parts of these communities that don't know forestry and all these topics, they may see a log truck driving them down the side of the road and have some kind of a reaction, emotional reaction, or they're driving by and there was a stand, let's say, and then for years, let's say there was a stand, and then they see an area where it was either thinned or cut, so harvested, right? Can you speak about kind of like, as we go into our conversation here, with both perspectives? There may be somebody who's really aware, and there may be somebody who's not really aware. And let's just dive in. How does this forest cycle work? And can you go ahead and get into some of these topics?
Yeah, sure. So, forestry and let's narrow it down just a little bit more and let's say the southern yellow pine
Mm-hmm.
forestry timber markets in the southeast, which is typically what you see the products that go into building materials are made of and your paper products. So let's narrow it down to that group. And so the typical rotation on timber is started with, you can look at it as either you started with the clear cut or you started with with the reforestation. So, typically a timber stand is reforested. We'll just start with the reforestation. It is
Mm.
reforested with either bare root or containerized seedlings. We can talk about that a little later. But that stand will be planted. It will be allowed to grow for about 15, on average, about 15 years. And then there will be a first thin. And typically in that first thin, you're removing the products that are either going into paper products or going into the interior walls of buildings, which we call two by fours, into lumber. And the remaining trees, or what is known as residual trees, after that first harvest has been taken, are then allowed to grow out for another 10 to 15 years, somewhere around the final age of 20 to 25. Now, if the landowner and the timber markets in that area are conducive and the landowner has it in his objectives, he can, or he or she can, perform what's called a second thin. And then they will go in and they will take out some more trees. And we can talk about later about why thinning is important to the timber stand. But, typically you do one or two thins and then you will do a final harvest. Well, the final harvest, the goal is in that final harvest for it to be 100% of your higher value timber products, which typically are your saw timber or your poles. And your saw timber is what goes to the mill and it's turned into your long term uh, forest products, such as lumber,
Mm.
plywood, stuff that is used in construction. Now that is a typical rotation, and I want to say this is no different. It is not any different than agricultural crops like corn, cotton, soybeans. It's just on a longer rotation.
Wow.
So, like with agricultural crops, where we get our food from, and we get our cotton for the clothes that we wear, the same thing it's the same process without the thinnings. You prepare the site, you plant the seed, you nurture the crop, and then you harvest it and within 1 year. Well, it's the same thing with timber, except it's over longer periods of time. And I think people that have a that are have mixed emotions about harvesting timber, they don't get that connection
Hmm.
because timber is such a long rotation that and look, in the southeastern United States, our rotation length is short if it's relative to like out in the northwest.
Hmm.
But 25 to 30 years for a rotation for us. People have mixed emotions about that. However, if you look at it and you at it on an environmental standpoint and you look at it from that avenue, it is very good for the environment because those timber stands that are growing are sucking carbon out of the atmosphere.
Right.
You're converting that carbon into lumber, which is a long term carbon storage.
Right.
So, everything is made up of carbon. So, if we grow that timber stand and it goes into lumber, it goes into utility poles, you're storing carbon from the atmosphere. How long does the average house last? How long does the average utility pole last? Decades,
Hmm.
sometimes centuries, as for large buildings.
Hmm.
So you're storing carbon that you have sequestered from the atmosphere into a product, and it's going to stay stored carbon. And then you're going to restart the stand, which is even going to pull more carbon out of the atmosphere. And then you're going to grow it out. And then it's just an ever revolving process. It never stops. And when you do that, you're just doing so much more for the environment. Whereas like using other products, you're not pulling carbon out, you're creating carbon. So, that's the beauty of forestry and how forestry helps the environment.
That's incredible, man. That's powerful. So I think another thing that I've been seeing. So recently, I went to Alabama. I was in Texas, and in Texas, I was visiting friends who manage their tree stands, their land, and it was very interesting, Paul. I'm gonna get to my question in a second, but we were riding a side by side, and we're driving, and we're literally riding through the managed stand, and then just we were basically on the edge of the property, and on the other side of the fence was unmanaged, and it was such a stark difference,
Mhm.
unmanaged versus managed. Can you speak to that? And I think it'd be very important to draw people's attention to, well, there's natural forests and these plantation forests, and that's maybe even more helps to illustrate the point that you were making earlier about lumber coming from trees that are a crop
Right.
planted on a long-term rotation. Can you speak to that, managed versus unmanaged?
Yeah, I'd be glad to. And I don't, like I said earlier, each individual landowner has his or her own management objectives.
Mhm,
And most landowners want to go back and manage their timber, but there are still landowners out there that they just want natural management. They want it to develop naturally. And
mhm,
I'm not going to say that there's anything wrong with that. That
mhm,
is, when I was in forestry school, I was taught about successional stages.
mm,
And as a forester, we manage successional stages. And what a successional stage is when you start off with I call it a blank canvas. It's just
mhm,
basically bare soil. When you start off with bare soil, there is going to be a natural stand of uh, plants that establish on that soil because
mhm,
that's what they grow in. And when you start with that, you're going to have what's called your light seeded species come in first. Those are usually your grasses. Then your forbs come in. Then you're going to go to your light seeded timber tree species, which is your pines and everything. And eventually, if you do not go in and have any inputs into the life of that stand, it will eventually evolve into a long lived hardwood, natural hardwood stand of what in the southeast in the southeast here it's oaks and other hardwoods depending
mhm.
on the site. So, but that takes a long time to develop. I'm talking about hundreds of years for it to
Wow,
develop into that.
wow.
So that's natural reforestation and that's natural environment.
Mm,
There's nothing wrong with that.
mhm,
That's Mother Nature.
mhm,
That's the way it was created.
mhm,
However, as foresters with management, when we get into managed stands, we pick out the section of that natural succession, those natural successional stages. We pick out the stage that we want to develop our products in. And that stage is typically in that middle where the light seeded timber species, i.e., loblolly pine, uh, come in and develop, and that's where we grow our materials from. So natural reforestation again is perfectly fine if that's your management objective and that's what you want to do. Managed forest on this side is perfectly fine if you're wanting to have a financial return from your forest. You want to create and help, and you want to create forest products for the world to use, and so that's the difference. We use both.
Paul, I specifically want to ask you maybe a couple of things. So, for example, I saw that stark difference I was explaining to you. We are actually on the side by side able to get through, and because it was managed, it was taken care of. There
Mhm,
was, there was shrubs and little bushes and such around. It wasn't just like a pristine. I mean, it was
mhm,
clear, it was clean. We were able to get through it. I'm just saying it's not bare. There are trees there. There's other plants, but on the other side of the fence, I saw. I mean, there was no way to get through it.
mhm,
We saw and observed trees that aren't growing straight like you'd want them to be, for harvesting purposes. They were falling over, some were dying, they were competing with other species. And so it's kind of
mhm.
like this hodgepodge where you can't get through it. It's not really usable. And at the end of the day, you could just see the stark difference. Yeah, I mean,
Yeah. Well,
maybe.
let's go back to something you said there, Vadim.
Yeah.
So you went back. You said there that the unmanaged stand was not usable. It's not that it's not usable. An unmanaged stand in its early years, its early successional stages, will come up
Mhm.
and is very thick like that. It
Mm.
is usable, but not by us. It's usable for wildlife that are adapted to that habitat.
Mhm.
And that's why forest and forest management is so diverse is you're looking at the big picture. And
Mhm.
those stands, yes, that stand was not usable by us for the products that it was producing, but there are still wildlife species that are utilizing that stand.
Yeah.
Over here, where you've got the managed stand and you could ride through it and you could, get into the understory, it's also usable by wildlife species. And
Mm.
but it's also you're basically using both. The unmanaged, it's only usable by wildlife. The managed, it's usable by wildlife and us as the consume producer and consumer.
Yeah. I guess could you define terms when we say use these different terms, managed, unmanaged? What does that mean?
So a managed stand is just like I said. When it's managed, you're basically having no inputs into it. You're
Okay.
letting it develop naturally.
Mhm.
Managed, you're managing those successional stages. You're going in and you're saying, okay, I'm going to go in and reforest. Well, I'm going to skip these first successional stages of unmanagement. I'm going to go in and start here instead of starting at A. You're going to start at maybe C, D, or E, and go in. You're going to handle that. You're going to replant the forest that after you harvest it, it's going to grow and it's going to develop into a mature stand.
Paul, another observation that has to do with what we're talking about is just observation. If we zoom out to the United States and we look at, the Northwest, very different forests and practices, and like basically the whole West Coast, maybe California included, is very different. The species are different. The terrain is different. In the Northeast, we have a lot of hardwood sawmills and a lot of guys doing hardwoods. But the South is a very unique
Right.
uh, place in the United States, and actually, I would say the world. I mean, I've been to a whole lot of different countries and have seen a lot of different things. I would venture to say that like the United States South, or specifically even Alabama, is like the way that Saudi Arabia is to oil. It feels like that's the way that Alabama is for trees. Like it's
Right.
so abundant and plentiful. Can you speak to some of those observations of what makes the South in the United States so unique, and specifically maybe Alabama, the regions that you're really familiar with?
Well, it basically comes down to our environment and also our landowning ability. I am a private landowner myself. I have two family farms that have come down through my family, and I'm a timberland farmer. In the Northwest, or as you go west, you get into a lot of more public ownership of forest, where you have more public forest. So let's take, let's take Alabama for instance. In Alabama, you may find this interesting. In Alabama, there are 23 million acres of timberland. Okay, all right. 93% of that is owned by what we call NIPF landowners, which is non industrial private forest landowners. 93% of that is owned by NIPF landowners like me, like a lot of my friends. And so we are blessed in the southeastern United States to be able to own land and to be able to manage that land and use that land as a uh, financial investment. Whereas in the other parts of the United States, and you have a lot of public land, then you have a lot of public input into that. So it's just like a lot of rules and regulations. Where in the Southeast, we have a lot of freedom with our land ownership. Okay, so also in the southeastern United States, what makes us another thing that makes us unique are our climates and environments. Okay, the climate in the southeast, we have, well, up until the last couple of years, we've had a couple of years of drought, but we typically have ample amount of rainfall. We have soils that are conducive for growing timber and the species that we want to grow that grows faster, that that can mature in 25 to 30 years. In the west part of the United States, you're looking at a stand that may take 80 to 100 years to mature. Whereas in the southeastern, with our species, they can mature in 25 to 30 years. So we have a quick rotation when it comes to forest. And so, and as in the north east part of the United States, they have a lot of hardwood forests there. They can't grow the species that we grow down here. So it's a combination of a lot of different things, but it basically comes down to environment and regulations.
Does it have something to do with just my personal curiosity? The closer you get to the Gulf of Mexico versus getting more north or away, is there a
Well,
correlation?
yeah, I mean that goes into the climate of the region.
Hmm.
That goes into the weather and the climate that we have here in the southeast, and it's unique for the entire country.
Wow. And I guess while we're on this zoomed out high level, I'm curious now too. Can you speak a little bit about? I've heard people say growth to drain ratios,
Mhm.
or that's maybe the term that's used in the industry, but outside the industry, people have this big question like, are there more trees now than there were before? Are we just mowing down the forests and destroying the environment? What's the truth? What do you know? What do you see, Paul?
So there's a lot of topics in that question that you just asked me, and to go back to the beginning and talk about growth to drain ratio. Um, we are, like I've just discussed, we are blessed in the southeast with climates where we can grow timber and we can grow trees, and we have a lot of open land, private timberland and pasture land that is very abundant in the southeastern United States. So when you get a situation to where you have ample amount of land and you have the climate to grow the timber, you have a lot of people that are investing in that. Timber is and timber utilization is driven by markets and it's driven by the economy. So when your growth to drain ratio gets what we call skewed from one side to the other, it's usually a product of markets and the economy at that time not using the wood. However, it doesn't mean that it's always going to be that way. Your growth to drain ratio is, like I said, directly related to your economy and products. We're losing or we have lost a lot of our pulp producing manufacturers or pulp utilization manufacturers, i.e., like in paper, because of a surplus or a supply. We've got a lot of wood on the ground. We've also got a lowering in utilization, and those markets are not as healthy as they have been in the past. So in the past, when people let's continue with that example of pulpwood. In the past, when the trees that were available for reforestation, I still remember my father talking about second generation genetically improved pine trees. It was the new thing that came out in the 80s and maybe even before. That, landowners were finally going to be able to get a genetically improved tree by selection, and was going to be able to plant their timber stands with it. Well, they planted so much and so many trees per acre that now there's a lot of those stands that are just overstocked. So, yes, your growth to drain ratio is skewed, but it's a product of overstocking, and it can be corrected by changing those management objectives. So that's why we have the situation with growth to drain that we have in the southeast.
Can you describe high level what's the situation? Are there more trees growing now, or are there less trees growing now?
We
Good
have,
part.
I mean, historically, we have more trees in the United States than we had when Christopher Columbus discovered
Seriously?
the country. Yes, we are more forested. we are more forested than we were when Christopher Columbus discovered America because of our reforestation practices that we have and our management that we're doing with the forest.
Well, that sounds incredible. I mean, we've built so much out of wood, since Christopher
Mhm.
Columbus, and still, you were saying we have even more now than when he was
Right,
just getting going.
right.
Dang.
Because I mean, look, let's look at it from the, you know, from let's just go back to the 1800s. And let's look at when the people that were using the wood, the settlers that were using the wood, and when we were not managing anything, there was a it was called cut out and get out. And they would just come across the railroads. They would come through the area. They'd cut the trees and just keep going. Well, they really didn't have, they didn't have anything to reforest with because the nurseries wasn't there. And the settlers, or let's just face it, it was the industrial revolution, and they were just needing the product to build the industrial revolution and keep it growing. They didn't know. We look at it now and go, man, were they so, that was so bad, was that were they so wrong? And they were. That was a mistake, but they didn't have the knowledge that we have today of management of timber.
Okay.
So, we do have a lot of timber on the stump, as we call it here. We have a lot of timber growing in the southeast right now.
Paul,
It's
that's what.
it's ripe for new products, and it's ripe for new industry to come into the area.
Well, so that's going to be my next question to you. Then is I love that you painted that contrast with the way that things were going, hundreds of years ago. Well, what's now? Can you now paint a picture of what's happening today? Specifically, just what is the topic of um, the genetics that you've brought up, and
Mhm.
what does modern technology, as you even called it, with genetics, what does that allow us to do? What is it, and what does it allow us to do that's now different, and is it better now than it was then? Can you please, big
It,
topic, go ahead and
right.
unpack all of that for us?
The answer to your question, is it better now than it was then, is a resounding yes. So let me go back into the beginning of that, and where we're going today and how we're going to mitigate or remediate that, the issue of the wood. We've got genetics has come so far, and the technology has come so far that we have trees now that are growing straighter, they are growing stronger. They are growing larger. They have smaller crowns, smaller limbs, so you have less waste. And that has all been through natural selection or selective crossing of these families. And it is, you're looking at, final harvest, where back at the beginning, when they would have a final harvest, you may get 20% of the stand that is able to be used for solid wood products, lumber, saw timber, because the genetics just wasn't there. And you would have few individuals. Now we're planting seedlings and developing stands that are producing 80 to 100% saw timber,
Whoa.
and it's producing less pulpwood. So the landowner now has the option, with his management objectives and plan, to go in and say, okay, we have a high growth to drain ratio. We have a very skewed growth to drain ratio. What can I as a landowner do to help the situation we're in? And it's a resounding, it's a really simple solution. You plant fewer trees per acre. You plant a better genetic. So those fewer trees per acre that you're planting, you're assured that 80 to 100% of those are going to grow into saw timber or a solid wood product, lumber. And you're planting fewer trees per acre. So thus you are helping manage not only the timber, but you're also helping manage for wildlife, because you're allowing more sunlight to get to the forest floor to grow more of the plants that the wildlife needs to survive. You're planting fewer trees per acre, so each tree is having is able, it has the availability to more resources from the soil, because there's only so many nutrients in the soil and there's only so much moisture in the soil. So if you plant too many trees per acre, each individual tree has less of those nutrients to use. Whereas if you plant fewer trees per acre and you plant a better genetic, you're increasing that individual tree's availability to those nutrients and that moisture that it can, thus keeping it healthier, thus keeping the environmental healthier, because a healthy tree is sequestering more carbon because it's growing more, it's pulling more carbon out of the atmosphere. Thus, you're helping the environment by helping the wildlife with creating the habitat that they need to survive. Because the number one cause for the declining in wildlife species, the number one cause for that is loss of habitat. You're creating habitat to help that. And then you're creating a product that is going to go into a long-term use product like lumber, as compared to a short-term use product like pulpwood, like that's used in paper, interior, the fluff pulp in diapers and stuff like that. So that's how we're fixing that problem. And that's why it's called technology. The technology is developing and it's evolving to help meet the demand of the economy of today and also help with the environment. And it's also helping level out that growth to drain ratio. Now, like I said back at the beginning of the discussion, timber is a long term, uh, uh, it is a long term crop. So it's a long rotation. That's why it's taking so long to even that balance. Whereas in agricultural crops, that balance moves quickly. In timber, it's very gradual.
Paul, you know what? I just want to know as much as you can share comfortably publicly. What does it mean genetically? You're doing things with the genetics of the trees. Like I'm envisioning you or guys with microscopes looking at something and these different things. Like, are there microscopes involved? What is it actually that you're doing? How much can you get into the weeds of this? But like, what does that mean? Technology, genetics, trees. Like, there's people. Okay, so like the fascinating thing to me, Paul, is this isn't just happening random. It isn't
No,
just like somebody's throwing some seed out there,
right,
and that makes sense because well, it's you got to be intentional with it. I think that's the word that comes to mind
right,
is with everything you're describing is you're so intentional. And Paul, you have a freaking PhD talking about the genetics of trees. Like what? Like we've got people like yourself who are deep in the knowledge and of the trees, of the growth, of the environment, all these different things. And I believe with that level of education, like it, and you're saying these things, it's incredible, right? Like there's
right.
so many naysayers out there that feel like they just emotionally are charged or attack our industry. But come on, people, like listen to somebody like Paul who's out there doing it every single day, seeing the results from before, what's happening today, preparing for the future. And like I'm bringing that word back, the intentionality. You're so intentional with what you're
Right.
describing. It blows my mind. So if you can take us into the what is that the genetics that you're describing, what's the process, what's the behind the scenes, give us a little glimpse, what does that mean?
So the genetic improvement in timber in pine started back in the 1950s. And it started at universities and they developed co-ops. Now, the co-ops were made up of universities and industry. And these guys came together and they said, look, we're not able to produce the products with the current trees that we have now, like we want to produce them. Let's go out and let's find pretty trees, quote unquote, pretty trees. So in the 1950s, they started looking for individuals that stood out to them that had characteristics of straight stems, small crowns, small limbs, less disease. And they started collecting material from this and they started growing it in what we call orchards. And then they would start and they would grow those orchards and then they would reevaluate them and they would take out the ones that did not look as well or did not have the characteristics that they needed. And then they would propagate or grow the genetics that did have those traits. Okay. So the first product that came out was called open pollinated. And open pollinated are just basically an orchard of trees that have superior traits that are pollinated naturally by the wind when the pollen is released by the male catkins, and it flies and it lands on the flower of the pine tree, and it fertilizes the ovule, and you get the seed out of it. Okay. Nothing too high tech about it other than, you're testing to see if they've got the traits that you want. Then we went on and said, okay, they're doing this in other agriculture where they are taking and using selected crosses. All right, this is not genetic modification. This is not GMO. This is the same thing that happens in corn, the same thing that happens in cattle, the same thing that happens in other agricultural crops, where you're taking two individuals and you're saying, I want to cross this individual with this individual, and let's see what that looks like. So then it come into what we call mass control pollinated, where we're basically just pollinating the flowers ourselves. And we'll put a bag over a limb in our orchard, and we'll protect those flowers from natural pollination. And then we will go in and we will take a selected pollen and we will cross pollinate that flower. And just because you do that, it doesn't guarantee that you're going to get a good end product, because they may not be compatible. I've always used the analogy. It's like an NFL running back marries a gold medal winning track star and they have a child. That child more than likely is going to be an athlete, because it's getting the genetic traits from the father, it's getting the genetic traits from the mother, and when they combine, you get a better growing tree. It's just like, Vadim, you're a genetic combination of your mother and father. I'm a genetic combination of my mother and father. I have some traits from my mother, I have some traits from my father, and you can look in the mirror and you can see those traits. I look in the mirror every day. My father had passed away in 2020, but as I get older, I look in the mirror and I see my father, because I have characteristics that were from him. Same thing takes place in timber. When you when you
What?
pollinate a tree
Yeah.
and you plant it, it's going to have the characteristic traits from its parents, wherever that came from. So you've got traits that you're wanting to pass on to the next generation, and those traits are being passed on.
Wow. Like, I just thought trees grow, and then you're telling me all this, which makes a lot of sense logically.
Yeah,
Dang,
yeah,
man. So it's again very intentional.
and it's all natural. I mean, it's 100% natural. I mean, there's nothing unnatural about it. It's just crossing two parents, and it's just like they do in cattle. When
Yeah.
you have when the cattle farmer and he has his herd of heifers, and then he takes a select bull and puts in the pasture with him, because he wants his calves to have the genetic characteristics of those mothers and of the bull. It's the same thing.
Okay, so keep going with the you were describing the technical process. You put these bags over the
Okay.
flower, you collected the pollen, you've somehow connected those. Now what happens?
Okay. So you collect the pollen from the male catkins. In the spring, before the flowers open, we put a bag over the stem with the flowers on it. In each bag is somewhere between 2 to 12 flowers. Okay. So that flower is not always receptive. She's got to start growth, and the flowers look just like miniature pine cones. They're pretty cool. But the flower becomes is open and becomes receptive for pollen. Well, you've got to have that bag over it so the outside pollen doesn't come in, and she's shielded.
Yeah.
Within that 2 week window, somebody has to visit that bag with a canister of pollen from a known male in a bucket lift, and they puncture the bag and they send the pollen in on the flower. They just spray the pollen on the flower. So you've pollinated the flower. Well, each one of those bags has to be visited 2 times, usually twice within a 2-week window, because at the end of that, she's only receptive for a small amount of time and she closes up.
Yeah.
She's not receptive anymore. So she's got to be pollinated in that time. Well, for that first calendar year after she's treated with the pollen, she just sits there. The flower does nothing.
It's
And then
weird.
the next spring after that, the pollen tube starts to grow, fertilizes the ovule, and the cone starts to form, which is where the seeds are enclosed in.
Yeah.
Those seed are the genetic, in each seed, you have the DNA from the mother, you have the DNA from the father. Okay. So when those seed grow, then we go back and we collect that cone. Now, people ask us all the time, how can you guarantee that cone you collected was pollinated with that male? Well, we keep, and I am thankful I do not keep up with this data, Vadim. We keep enormous data records of what family this tree is, what family it was pollinated with, and there is a tag on each limb, each branch with those flowers. There is a tag that denotes that cross. That tag, just like the chain of custody for an investigator who is investigating a crime, when he collects his evidence and puts it in a bag, he has to sign a chain of custody. Well, this is the same thing here. When you collect those cones, that tag and that chain of custody has to be documented so that we are over 95% sure that that tree, that seed contains that combination of those two parents. So when you call me up and you say, I want AGM 37, I can guarantee you within 95% certainty that the seedlings you are getting are that cross, that family. And Vadim, on top of that, I can guarantee you that those seedlings that are out there are full siblings. Just like we have siblings,
Yeah.
and some of us have half siblings, some of us have full siblings. Those trees are full siblings. They have the same mother, they have the same father. So
Okay,
those
hold up. Before
seed,
we
okay, go ahead.
hold up. Okay, bring me back to the cone because
Okay,
I wanna understand the whole process. So bring me back to the cone. We'll get back to the siblings in a
okay.
minute.
So
But
when the
what you
cone,
took the cone, and
okay,
when I see a cone, we see pine cones and fir cones, which there is a difference, right?
yes,
We see cones on the floor in the park or when you go to the forest.
right.
What are you seeing on the floor? Is there anything alive in there still?
No,
That's usually just that's the carcass, isn't it, kind of
that's
thing?
that's that's the old flower is what that is. That's the cone is the old flower, and she has already opened up, and the seeds have been dispersed.
With the little helicopter deals,
Yes,
right? What's all
yes.
that called?
The little wing that is on the seed, you have two different types of seed. You have seed that are what you will want for pine. You have wind dispersed seeds. So the little wing that's on it is
Yeah,
on there so that when it is dispersed from the cone, it catches wind,
yeah.
it catches the wind flow, and it will fly on the wind, and it can disperse them over longer distances, unlike an acorn from an oak tree, and you know they just drop straight down.
Yeah,
So for a pine tree, it has a little wing,
yeah.
and that's what's interesting about that is it will fly for long distances. So
When
what
does it
you're seeing
decide
on the
to
ground is the cone.
how does it decide to start flying? What's the mechanics there, do you know?
When the cone opens up,
Yeah, and
when
it's
it
not
gets
held
to the
in anymore?
stage when it gets to the stage in life that it has the growth inside of it has stopped, the nutrients coming from the plant, from the tree, has stopped going in and feeding the cone with the nutrients that it needs to grow and the seeds to develop. When that all stops, the cone basically dies, and then when it does, it pops open.
What causes it to pop open? Is it heat or mechanics or
Little bit natural environment. Natural. I mean, a lot of different facets. It's
that's so cool.
it, individual, environmental, a lot of different things.
So naturally it'll pop open and they start flying away. You can't
Yes,
let the flying away and get all of them mixed up because you're tracking all the data, right? So what
that's why
happens
we collect. That's why we collect the cones before they pop open.
Genius. Okay. Okay, now you've
So
got
when the cone, you asked me what causes it to pop open. When it naturally dries down, it will
uh-huh,
open and release its seed. When the
uh-huh,
nutrients and when it's when the nutrients and the moisture stops from the plant and it dries down, it will pop open. We
uh-huh,
collect them before they open. Keep them with I mentioned the chain of custody. Keep them all together.
uh-huh.
We dry them ourselves, which causes them to pop open, and then we extract the seed.
Okay, cool. So now you've got a seed that doesn't need to fly nowhere, but it's got a wing, just like the ones in the nature. Then what? Then you start planting them, and
Then they go into a process of storage where we can store them. Sometimes store them for longer periods of time.
oh,
And when it comes time to plant our nurseries to produce the seedlings that are
mm,
going to eventually be sold to the consumer to be planted on their property, the seed are sent to our nurseries. They're planted they're planted in rows where this block of seedlings are all the same family. This block of
mhm.
seedlings are all the same family, and they keep very very detailed records of what seedlings are planted where, which families planted where, and then they're grown. That's like, I was talking about the mass control pollinated seedlings. It takes 3 years, Vadim. It takes 3 years from the time that pollen is introduced into the bag before that seedling is sold to the consumer.
Dang man. And
Because
when you're
there's also a process in early spring where the seed that is going to be used to be planted in the nursery, it has to go through a process called stratification, which we is a process that basically weakens the seed coat so you get better germination.
the heck does that mean? What did you just say? That's geneticist speak right there.
So you go through a process called stratification, and it happens naturally in
Yeah.
nature, and
Uh-huh.
it usually happens with cold storage. But there's a lot of different ways to stratify seed. But basically, a seed. There's the different parts of a seed. You have the seed coat, and then you have the embryo that's inside. Well, the seed coat is just a hard outer layer, and it sometimes the seed coats can be so hard that the little embryo inside has trouble breaking out. So you put it through a process called stratification that weakens that seed coat so that the little embryo can start its root growth and then it can start its shoot growth.
Paul, I heard this somewhere. Maybe you could educate me, but like on that topic, somebody said somewhere that like sometimes fire in the nature is what causes
Mhm.
things to start growing. Is that true? And how does that
Yes.
relate to what we're talking about here?
Yes, there are certain species of pines, not loblolly, but there are certain species of pines that cone does not open naturally.
Huh.
Okay. It stays closed because it has a high resin content in it. So its
Uh-huh.
resin holds its closed. The
Uh-huh.
only way to get those cones to open is
Yeah.
with the usage of fire, because
Gee.
the heat has to melt that rosin content that is in that cone in
Uh-huh.
order for it to open, because it's just like glue. The resin that's inside the cone is holding it together. And until it gets fire, it's not going to open, because until that resin is heated and melted, it can't open. So, that's another topic. Like at the beginning of the podcast, we could spend days talking about prescribed burning and the usage of fire in our natural forest. And it's a tool that is used under management.
Let's hold off on the fire
Let's
topic.
hold off.
Let's hold off on that. Back to the seed. Okay, so now you were explaining to me stratification.
Hmm.
That was where you were helping the embryo inside start growing.
Right.
Well, what when you're doing this in the nursery or in the field, it does it naturally. What actually kickstarts the growth of the new seedling? Like, what the heck? Like, you've got this thing that just drops into the soil, or there's probably a more methodical way that you can explain this, but you need to water it, and then it's just like it's got a program that it kicks off, and it just like does its thing. Like, how does it happen?
Just Mother Nature. I mean, that's just in the way it was, when the seed gets the moisture and the soil temperature gets to the right temp,
Yeah.
the embryo inside will start growing. You will start getting cell division. The cells will start dividing, and just like with cell division, and just like in anything else that grows, the cells start multiplying, and when it gets so big, it pops the seed coat, and then it's just, it's like any other um, individual. Then you start having the root develop and the shoot to develop. So it's just nature.
Jeez, man. Okay. So, but is it like you gotta like really? I can't do it in my backyard, or can I? Like,
Yeah,
how
yeah.
critical are the conditions, and how specialized is the process that
It's just like planting a garden in your backyard.
you got to
You
take
know,
care of?
you can't plant your garden in the dead of winter and expect it to grow because the conditions are not right. The soil temperature is too low. There's too much. There's not it's too cold outside. The seed is
Mm,
just going to sit there. It's not going to grow. So
mm.
when the temperature gets right, and when the high enough, and the soil temperature gets high enough, and the moisture is there, it's like start.
That's the kickstart.
It just kickstarts.
Dang, man. Okay. Okay, and then so from that moment when you planted in the nursery to seedling delivered to customer, I mean, can you describe a little bit about like seedling? Is it a little guy? Is it like how tall is it? What's it look like? What's the perfect seedling that can survive on its own out in the wild? And so can you describe what's the actual product that you sell? That's the seedling you call it. Describe it, and then take me back to how you get that result from these seeds you're telling me about. So two-part question
So
there.
the perfect size seedling, is what we had called a grade one seedling, and a grade one seedling has a 2-to-1 shoot to root ratio. Now, what that means is a 2-to-1 ratio is the top part of the shoot of the stem. What is above ground is 2 times as long as what's below ground. Okay. Average seedling is somewhere around 12 inches tall, and your ground line diameter is about 4 to 5 millimeters. Now, how we get that is we have some very good nursery managers who are nothing but, I mean, they are just great growers, and they know when to apply nutrients to the nursery bed. They know when the seedlings are lacking this nutrient or they need more of it. They know when the seedlings need to be watered. They nurture the seedlings all through the growing season because it's like an agricultural crop. And then at the end of the growing season, when the temperatures start dropping and it starts going, and we start like we're transitioning right now, we're in fall, fixing to go
Mhm.
into winter, and the temperatures start dropping, daylight starts, the days are shorter, the trees
Mhm.
start going into what we call dormancy. But back to your question about what the perfect seedling looks like. It has one main taproot, and then it has so many first order lateral roots. So you want to look at those roots, make sure there's plenty of what we call fibrous roots or hairy roots on it. They look like little hairs. The shoot typically is twice as long as that root section. It has it has its little limbs, and has obviously a really dark green color, and I don't know any other way to explain this other than saying it has a very strong pine smell. I mean, you can just smell them, and they smell like pine trees. That's a perfect seedling.
Why do they smell the way they smell?
The
What is
resin that's inside, smells like what I used to when I was a kid. I called it pine sap. The resin that's inside that is basically the blood of the seedling.
man? There's so many follow-up questions here. Okay, I know
Oh,
this is like super. You would say it's like trees. It's like basic. You would say, but it's
Vadim,
there's so much depth there.
It takes 4 years to become a forester, and then I went on in masters and then PhD, and we are trying to do a podcast for about an hour and a half, and there's so much information and so many rabbit holes we could go down. I mean, we could do a podcast just about prescribed fire. We could
Yeah.
do a podcast just about machine planting versus hand planting. We could do a pod. There's so many of them, But it is that's what's great about forestry, and that's what's great about my job, and that's what's great about my career that I chose.
Paul, is it true that trees can talk to each other?
Yes.
Well, what? To give me like
So,
a little glimpse of that.
but but
What is?
but let me preface that with no, it's not like you and I are talking right now.
Uh-huh.
Okay, so trees can sense uh, from the tree adjacent to them when there is stress, when they are being stressed. So, getting into another topic, let's use it as an example, southern pine beetle, which is a beetle that attacks trees in the southeast, and it's very detrimental. It's a major issue, and it's happening right now because we have trees that are we've been through two years of drought, and we have trees that are stressed. So when an individual tree um, is attacked by a southern pine beetle, by the female, and she starts burrowing in, that tree starts putting on a defense to basically defend off the attack of that southern pine beetle. And it's what we call pitching it out. Well, the pine tree uses the resin that's inside to pitch the southern pine beetle out. Well, if the tree doesn't have enough resin to do that, then it can't fight off the attack of the southern pine beetle. It has been documented that trees around that individual that has come under attack will sense the attack and will automatically start trying to produce more resin.
Whoa. But how do they know? How does one tell the other, like on a walkie-talkie or something? Or what is-
You answer that. I don't know.
Wow,
Yeah.
man. But it's like it's observable that's happening.
Right. I mean, it's observable. This one tree over here, this one individual in the center is being attacked by a
Mhm.
southern pine beetle. And
Yeah.
then you notice an increase in resin production by the individuals around it. So there has been some type of, for lack of a better word, communication there that has caused those individuals around it to realize, hey, man the battle stations. I've got to get ready for a fight because the attack is coming.
Okay, well, hold up. Let's not go into fire. Let's not continue down the path of resisting like all these different diseases that can happen. Um, just to finish the train of thought, we got all the way to seedlings ready to go. What happens to bring? Sorry, I went on a tangent, and that's really interesting for you. I really enjoy that. But to bring our audience back to seedlings,
So
we've now got
seedlings,
to seedling. Yep.
so seedlings, once they reach that size, once they reach that seedling size at the end of the first growing season when they're planted in the nursery,
Mm-hmm.
then when the temperatures start dropping, we have what's called chilling hours. And a chilling hour is basically when the temperature has been below a set point minimum, or a set point, and it's usually somewhere around 45 degrees. But the trees start going into what we call dormancy, and they are sensing, okay, it's time to go into dormancy. The growing season's over. We're not going to be growing during the wintertime. So basically, they're going into their hibernation stage. All right. That is the best time to take the seedling out of the nursery bed, transport it, and plant it in what I call its final resting place. So it's actually, but in this sense, it's the beginning of its life, but it's where it's going to be until it's harvested. So our nursery managers then start lifting the seedlings. They start taking the seedlings out, processing them, packaging them in bags. That is, each package has is identified by the family of that tree. What family is that, or what genetic is that that's going in that bag. They are put in cold storage in coolers that we have our nurseries, and then they are loaded onto trucks that have refrigerated trailers that keep that temperature low, and then they're transported to the consumer to where they're going to be planted. Then they go into the process of planting, where they're planted into their final resting place, where at the beginning of the next growing season. When the temperature starts coming back up, days start getting longer, the environment starts getting the climate starts getting conducive with vegetative growth. Then the just like you see in the spring, the sap will start rising out of the roots. The shoot will come back out of hibernation, and you will start seeing bud growth. And when you're seeing bud growth, that means you have root growth below soil.
And I want to go talk about the tree going up, and I want to go about talk about the roots going down. So,
Right,
man,
right.
okay. So what? Another basic question here for you. I mean, what's required to fundamentally grow? Like you're talking about now, it's coming out of hibernation. It's now in its final resting place. Um, Shoot. Well, I guess I skipped over. How do you determine final resting place? And maybe you can start with that, and then what causes them to now grow and take final form?
So you're not going to take a tree, talking about determining where it's going to be planted. You're not going to take a tree that, even though we're the southeastern United States, there are different climates within the southeastern United States.
Ah.
So you have in my area, I deal with, and those are called regions. And in my area, I deal with the coastal region, which is basically Interstate 20, midway down through Alabama and Mississippi. South is the coastal,
Mm-hmm.
and everything above that is the what we call the Piedmont region. All right, so it's not.
Piedmont, you
It's
said?
what's that?
What did you call it? That's a Piedmont?
Piedmont
It's P I
region.
G M O N T.
Pied
Yeah. Okay.
Moet.
Okay.
And so, you're not going to take a tree or a family that is uh, from the Piedmont and transport it to the south to the coastal and expect it to grow well,
Oh.
because the genetics, you've got trees, you have families that grow well in the Piedmont that are adapted to their soil characteristics and to their climates, and you have families that are more adapted to the coastal region and their soil characteristics and their climates. And it all basically, the majority of it comes back to minimum winter temperature. The families that are in the south or on the coastal region are not adapted to the colder temperatures of, say, North Alabama, North Mississippi. And likewise, trees that are from north or from the Piedmont, they're not adapted to the climate of the coastal region. And that all goes back into natural selection, back, ever how far you go back to where, the genetics, the individuals survived in the north that could handle the cold, and the individuals survived in the south that could handle their climates. So just because you have a good family for the coastal region doesn't mean it's going to be a great family for the Piedmont, and vice versa. And that's where I
Understood.
come in, working with landowners also. So when
Understood.
a landowner calls me up and he or she tells me, I want to grow a tree, or I want to plant a tree that's going to produce this much uh, uh, hard solid wood product, saw timber. I want it to do this. Pick me a family that is going to grow on my area. And it's not, I can't just go out and just say, okay, just give me that tree because it's going to grow there. No, you can't do that, because that family may not be from that region and may not grow well in that region. That's why we have our trial areas. We have over 800. We have trials planted across the southeastern United States, where we plant these families in trials before we release them for production to go out to the consumer. We have to test them
Hmm.
to make sure they're going to perform.
That's incredible.
So we have over 800 trials across the southeastern United States where we have these different families planted, and we can go down through and say, okay, this family is a great performer in the coastal, but it's not doing anything in the Piedmont. Or we tried this crossing this mother and father, and even though they're both great parents, their offspring is not doing that well.
I
So
gotcha.
then we can determine, then that's where I come in, and like working with a private landowner, I can say, okay, here's a list of the families that will grow well on on your property in your area. And
I gotcha.
here we have a score system called PRS, which is performance rating system. And I can give that PRS to the landowner, and the landowner can look at it and say, all right, or I can hand it to the landowner and say, this is how your trees are going to perform on your property.
And that's where your expertise comes in again directly. Why you need to be on site, and like you were explaining, that's your kind of day to day. You do this as a service to be able to educate people, and then they make the final selection. That makes sense to me.
Exactly.
I can we wrap? I I have a lot more questions because this is trees. This is the Wood World podcast. I mean, this is what the people want to hear, right? And it's
Right.
really upstream where everything starts. So I'm fascinated, Paul. Um, I guess to finish the conversation about you took me through the seeds, through the seedling. Now the tree's planted in the right spot, which is that's your expertise. Love that. And then, hey, I mean, what are the basics for a tree to grow to maturity?
You know, that's $1 million question that has got a lot of inputs, because you have environmental factors that come into play. What it takes for a tree to grow to maturity is it takes ample nutrition, ample nutrients, just like you and I do,
Hmm.
just like our children does, has those needs. They need ample moisture. They need time to grow. They need room to grow. You've got to give a tree enough room so that it can grow, because if you plant too many trees per acre and they're just really thick, they don't have enough room to grow, even though they have the genetic capability of being a superior tree. If you don't give them the room to grow, they're not going to be able to express, those genetics are not going to be able to express themselves. So they're just not going to come out, you know.
I just
So,
wanted to make sure I understand the list. You said you need nutrients,
right,
you need moisture.
right.
I assume you said environmental, so environmental probably means sunlight.
Sunlight
So you got nutrients, you got moisture, you got sunlight. What else?
and room to grow.
Room to grow. Um, I mean, how does that come together and get you like a full size beautiful tree? I mean, and don't I would say like we really probably should do a follow up podcast,
Yes.
but give me a little bit, give me a little taste of how does the tree take all that and grow into something beautiful, majestic, and then productive, man.
But Dame, that's $1 million question that you
Yeah.
could spend a long time explaining. It's the way God intended it, and it's the way He created it.
Isn't that just incredible?
It is
Man.
incredible. It is amazing. And you see why I'm so passionate about it and why I love them. I love trees and nature so much, is because and it's not just I love pine trees, and it's not just I love hardwoods. It's all of it. It's the whole process. You know, I've stated before, when God created the earth, He created it perfect. And even God Himself said in the book of Genesis, it is good.
Yeah.
It is good. He saw that it was good. He created it. It is good. And He said that. And for God to say that it is good, it's great to us.
I absolutely agree. And wood is good, right? You touched on it briefly.
Wood, wood is incredible. To me, there's nothing no more beautiful than the wood grain in lumber, and using that. I mean, the interior of my house, most people have painted walls, like the wall behind you, like the wall is behind. The interior of my house is lumber from Barge Timberlands in Wilkesville, Mississippi. And it's just lumber. It hasn't been painted. It hasn't been stained. It's just lumber. And I sit there at times in my recliner, and I just look at it in amazement of that grew. And all of those grains that you see, which are growth rings, all you see in that is a moment in time when that tree was growing and it was getting what it needed and it was producing what it was producing. It was growing into something. And it's nature, it's natural. There's been studies that people feel better when they're around nature. People's attitudes and personalities improve when they're in nature because it is all of us. We are. It's every. It's all around us, and it impacts us so much.
I'm
So
just
you
blown
see
away.
why I do. You said you wanted me to tell why I do what I do.
Yeah.
You just see it. I mean, 23 million acres in the state of Alabama is timberland. 93% of that is owned by people like you and I. That is you. That's a legacy.
Mm.
Dean. You're leaving a legacy. A landowner is leaving a legacy, and it's like a painting. You can paint your portrait the way you want to paint it, and when you're gone, that portrait is going to remain. And people are going to look at that and they're going to either say, man, he should have done this, she should have done that. Or the descendants, the grandchildren, the great grandchildren are going to look at it and go, man, grandmother and grandfather painted a beautiful portrait. And now look what we've got. And they're going to be remembered by that. Everybody wants to be remembered. But Dean, you want to be remembered for what you did with your life at the end of it, because that's your legacy. For timberland owners, that's our legacy.
Yeah, which means you absolutely want to do the best for the land, which is optimal for both conservation, being productive with the creating the resources that we need, the wildlife that you mentioned. So all of that comes into play. You're not just trying to mow down everything and
No,
make a buck. It really
no,
has to do
never.
a lot more with the legacy you're speaking about. And I think that, well, to wrap, give us your what would you want maybe there's two groups of people listening, right? The people who already understand this topic and they're really in tune with us, and there's people who don't. But if you were to just give us this your closing statement, your call to action to us, Paul, what do you want people to walk away from this conversation and really think about or think on or have a new approach, a new mindset? What would you encourage people to know to want to walk away from here with?
Look, we have some timber markets now that are not uh, the best they can be for timber products. That's true. But markets are dynamic. They're always changing. Technology is always evolving. There's going to be new products that come out. Just because you're planting a seedling today doesn't mean it's going to be harvested in the markets of today, because
Mm.
it's got to grow for 25 to 30 years. And I can guarantee you those markets are going to be different than the markets they are today. So at the end of the day, in your plan and in your objectives, you can't plan for today. You've got to plan for tomorrow, and you've got to plan for the next market, because you're planting an individual plant that is like a share of stock, and it's got to grow just like that share of stock has got to grow. And you're buying that stock because of not what it's worth today, but what you want it to be worth tomorrow. And Einstein's definition, I use this phrase a lot. One of Einstein's definition of insanity is doing the same thing over and over again and expecting different results. Warren Buffett had a saying that and I quote Warren Buffett, price is what you pay, value is what you get.
Price is what you
Okay.
pay.
Now
Value.
I think both of those individuals were successful and very smart people, are very smart people. So with those two ideologies, you've got to plan for tomorrow. And your management plan, if it has anything in it that I want to produce solid wood products, I want to manage my timber for a economic return, plus I want to manage for wildlife habitat and everything else, you have got to look at what is available. And price is what you pay, value is what you get. So when you decide, and listen, Vadim, if you don't hear anything else I say today, the wrong decision today in timber is going to follow you for the next 30 years. So if you make the wrong decision today and you plant something that is not going to meet your management objectives, or you decide to take whatever is available, 30 years from now, you're still going to be regretting that decision. If you do it right today, 30 years from now, if you're here or if you're not, your decision is going to be, your right decision or wrong decision is going to be evident. So I go back to that painting your portrait. When you're painting that portrait and you're sitting there and you're going, I want my descendants to look up and say, I made the right decision. Or do you want them to look up and say, he took the cheap way out?
Hmm. Wow, Paul, thank you for that closing statement. And then also, just ladies and gentlemen, if you're paid attention to this far, you can absolutely see how this wood world, it goes deep. And you talk to somebody, whether in a sawmill that prepares saws, or you talk to somebody like Paul, who is all about the genetics of trees. There's so much depth, and what we heard today from you, Paul, is incredible. I love the fact that, I guess, what I'm hearing, to summarize, is it's so intentional. It
Mhm.
really, like you just summarized at the end, you got to make the right decisions, and you got to be intentional. And that's what I love about our industry. And I'm encouraging our industry to step forward and be more transparent rather than less transparent, to educate, yes, ourselves who are in the industry, but also the folks that are outside the industry. It's so helpful to hear somebody may absolutely not be wanting to buy seedlings, but if they understand how intentional, Paul, you take your job, and the landowners, what they're doing, and how on purpose things are, it's not just cutting trees down and planting something back, and it's not just for a check mark. Wow, this powerful. So I really enjoyed our episode, Paul. I also want to remember one thing you mentioned is one thing that you mentioned when we were together. You mentioned to come out when you're going to be doing that 2 week window with all of the bags and the flowers and all that. I would love to take you up on that and do like
Yes.
a on-site vlog. We'll coordinate all that.
Yes.
Man, I this has been fascinating just to get information, but eventually I want to follow you around, see the trees themselves, see the cones, talk on site somewhere, and
And
follow
I
you
would
around.
like to say, if any of your listeners would like to contact me or would like more information, please go to our website, www.arborgen.com,
Yes.
and they can find my contact information on there. They can, or if they're in a different area, they can find my colleagues' contact information on that as well. We
Hmm.
also send out a twice a month a tree lines newsletter, which is it contains information about planting season, seedlings, all sorts of educational information. They can sign up for that on the website and just take a look at it. And if you have any questions, contact me.
Thank you so much, Paul. Thank you
Thank
so
you.
much. This has been a very informative conversation. I look forward to spending some time with you in the future as well. With
Oh, I
that,
can't wait.
we're gonna sign off, and thank you so much for staying tuned and listening to what Paul Jeffries has to say about seedlings, genetics, trees, growth on the Wood World podcast. Your host today, myself, my name is Vadim Kovalev, and the podcast is brought to you by our company called Koval. So stay tuned for the next episode. Thanks for staying with us, and enjoy what's coming.